This lecture is about testing in the software lifecycle. Types of testing performed in the software lifecycle are unit testing, integration testing, validation testing, alpha testing and beta testing, security testing, system testing, recovery testing, performance testing, stress testing, and regression testing. Unit testing is testing of each module or class. It is usually performed by the developer. However, it can be performed by peers or testers. Test-driven development, TDD, is required or recommended, and it is a trend in the software industry. Functional testing, structural testing, interface testing, security testing, and exception testing are performed. The testing process begins with test cases that drive the test. The component under test is evaluated. Test cases are executed and the results are collected. Test stubs are used when the component under test communicates with unavailable components. After the tests are performed, the results are reviewed. Test-driven development requires writing of tests before the features are implemented. The tests are written in a language, perhaps JUnit. The tests are run and they should fail on the first try. The production code is written or modified, and then all tests are run. If a test fails, then the code is modified. If the test passes, then ask if more features are to be implemented. If yes, then go and write the test for the new features. If no, check if the test coverage is complete. If yes, stop testing. If no, add test to increase the coverage. Traditional integration testing has been performed in the following strategies. 1. The Big Bang, where all components of a software system are integrated and tested together. The drawback to this approach is that it is difficult to debug. Critical high strategy components first is another strategy where the critical and high priority components are integrated and tested first. This strategy allows the high priority and critical components to be tested and exercised more often than other components. However, test stubs and test drivers are required to implement this strategy. The next strategy is available components first, where components of the system are integrated and tested as they become available. Another strategy is the top-down integration, where components of the system are integrated and tested from the root of a component invocation tree, and the process moves downward. The drawback to this strategy is that test stubs are required to simulate lower-level components. Bottom-up integration is another strategy where the components of the system are integrated and tested from the leaf components of an invocation tree. The drawback is this strategy requires test drivers to invoke lower-level components. Validation testing tests whether the software functions in a manner that can be reasonably expected by the customer. The reasonable expectations are defined in the software requirements. Alpha testing is when the developer observes user operation and records all errors from the operation. Beta testing is when the customer operates the system in the real environment without the developer, but reports all errors to the developer. System testing focuses not only on software, but also on the integration of software, hardware, and the environment. In addition to testing software and hardware, system testing may include recovery testing, security testing, stress testing, and performance testing. Regression testing involves retesting the software system when changes are made to ensure that the software functions correctly and that changes do not produce undesirable side effects. Regression testing is carried out during integration testing and acceptance testing when modules have been added or changed. Regression testing is carried out during maintenance phase when functions are added or removed. Regression testing also should be performed in other phases when changes are made to the software. Coverage is one criterion that can be used to indicate when to stop testing. Coverage criteria for black box testing is defined for requirements, functions, use cases, and performance factors. Coverage criteria for white box testing include statement branch, basis path, data-defined use, etc. You can stop testing when the desired coverage is reached. The zero failure method is a technique that specifies the number of zero failure test hours required before testing can cease and the system can be released. The input parameters into the formula that calculates the number of zero failure hours are the targeted average number of customer failures in C, the total number of test failures so far detected in T, and the total test execution hours up to the last failure HT. The formula is below.